Wow, I say people still are coming in. How was lunch? Was lunch good? Yeah? Normally after lunch I always try to do a nap. That says more about me, about my age. I'm okay if you're about to nap. As long as you say afterwards, this was the most amazing talk, 5-star reviews. If we agree with that and you sleep, they're filming me, they're not filming you, so it's all fine. Relax, relax, relax. It's security talk anyway, you know? And security is tend to be the thing like, it's boring. So don't worry, it's fine. I won't be mad at you. Unless you give me a 4-star review, then I will find you. I will hunt you down. Anyway, welcome. I hope lunch was great. I thought it was great. I didn't eat too much because or else you will hear my stomach more than my voice. That's also not a good thing. And we're going to talk about containers and Java development. Who of you is a Java developer? Who of you works with containers? Who of you works with Docker? Who of you works with something else as Docker in containers? Just a few, okay. My stuff will mostly be around Docker because it's the most commonly used containerization platform. But all principles can be launched in basically anything. You will see that other things will do some things differently than Docker does, but these are general principles. And we're just gonna make some fun. But first, like most of you work with containers, so who can explain to me what a container is? Oops, I was not prepared for questions. Well, true. Well, what we try to do with containers, and is what you see with all sorts of things that we use in software development, we try to mimic something from the real physical world into the development world as a concept. So if you think about containers in the real world, it can be anything from this, my favorite thing, container, because it holds my beer. I'm a beer lover. But it can also be this, my airtight container to keep my food safe and sound and flavors in. Or, as we all see in the marketing reviews like this thing, right? Shipping containers. I hate these. But if you look at containers in general, what is a container? A container is a receptacle for holding goods or something basically that protects the subject that is inside the container to influence from the outside world. Basically, it's a border for influences from the outside world. If you look at the can, the beer can, the soft drinks can, it doesn't matter. It tries to preserve flavors, preserve carbonation, and it doesn't respond or react with any oxygen from the outside. Airtight container tries to prevent that this air coming in and my food gets wasted. Shipping container is there to preserve the goods that while shipping, they stay intact. Most important thing here is that you pick the right container for the right thing. I mean, it probably makes sense to put beer in an airtight container, but if you just drop it in a shipping container, I'm not sure if you want to drink it anymore. So picking the right subject is very important. What is the purpose of it? So let's transpose this to software development. Say our Java program, we want to put it into a container. Why? Because it's cool. So we put Java in an airtight container, and then Java's dead. No, I'm kidding. Juke is still alive. So let's make sure that it's alive. But what do we need to do with containers in software development? We probably want interaction with it. So it's not just a border between what's inside and protecting it from the outside. No, we actually have to interact with the outside. If your Java program is there and doesn't interact with a database or human input, it is pretty useless. You can try it and see how much money you get out of it, but probably none. So you cannot just transpose the way of, hey, I am taking a Java program, and this is how managers think, right? Let's put it into a container, and then we're secure. Unfortunately, this is not the truth, because supposedly it's a container with holes in it. It has connections to the outside world. Yes, some things are sandboxed within that container, but some things you need to make sure that it actually works, or else it's useless. And that's not what we want. So, this is me. I'm Brian. I'm a staff developer advocate for Sneak. If you ask 20 developer advocates what developer advocacy is, you'll get 50 different answers. So I cannot answer you what I'm doing. Mostly I say, I used to program and now I email a lot. That's pretty much what I'm doing. I mean, Java champion, stuff in the community, blah, de blah, de blah, de blah, not important. We're going into containers, and I'm picking Docker containers because of this. by average 1 billion weekly downloads of container images from Docker Hub. So it means it's a big player. This was actually a number from 2021, so I'm not sure what the current number is. You feel it, it's huge. Now I sound like somebody else, it's huge. Never mind. But I'm gonna tell you a few things. Basically, I'm gonna narrow it down to 5 tips not to fail your security if we specifically look at containers for Java development. So, first one, choose the right Docker base image for your Java application. We just mimicked it to the real world. Putting beer like this in a shipping container doesn't make sense. What is the first line if you write a Docker file? From what? Alpine doesn't, yeah, it depends. If you don't need to use glibc, you can use Alpine, or it's from Ubuntu, or from whatever, or from something that I randomly grabbed from Docker Hub and blindly trust. In 2019, end of 2019, early 2020, I did a research for Sneak, where we downloaded the most commonly used base images from Docker Hub that were freely available, that I didn't have to pay for it because I'm Dutch, I'm cheap. And we scanned them for vulnerabilities. This was the effect. Fun thing is, my manager, my direct manager, is a Node.js developer. We had so much fun. Point is, this is 2019, so this is old. Thing was, at that point, I just downloaded, like everybody did. Hey, how do I do this? I picked the thing from Stack Overflow, put it in. So there was no tag, there was no hash. It was basically just downloading the latest. The latest node image at that point was based on full-fledged Debian Jessie. Oops. Do I need full-fledged Debian or any other operating system for my tiny microservice? Think about it. Probably not. So somebody already screamed Alpine. You're on the right spot. You don't probably need the latest image. You need to look further. You need to look what is actually going on. And it makes sense to look at different tags, because in that same thing, we looked at different base images based on different operating system, because our base images depend on something else as well. And it makes a lot of sense if I just look for the same application or the same container based on a different operating system. Like if I go from Debian to Ubuntu, I already save pretty much half of my problems. And it's not that all these problems are directly exploitable, but every operating system comes with a ton of binaries. And these binaries can play a role in a chain of attacks. What I will show you as in hacking, you will see pretty much direct hits, but most of the hacks are complicated. And they try to come in, they tangle something from one thing to another, let's use that in the loop, and then boom. And we don't want to give attackers more ammunition than we need, right? Plus, do I need a huge container for my microservice? Probably not. So if you can go to, for instance, Alpine, if you don't need to use glibc, why not? So pick the right one. October 23, I did the same thing for Eclipse Tamarin. The default image is based on Ubuntu 22. And that had 35 vulnerabilities. And basically all these vulnerabilities that I showed you were traced back not to the application layer, so in this case Node, what I showed you before, but to the operating system layer. So picking the right operating system for your image makes sense. Luckily, they all related to for Eclipse Tamarin, they used Ubuntu 22 as the default. But if you want to go for a larger one like CentOS, go for it. That gives me a job, at least. Yesterday, I did the same for Java 21. CentOS is not available anymore, not pre-packaged. Of course, you can do it yourself if you want to streamline it. But again, the default is Ubuntu 22. But it makes sense to see if you need to use all the features that come with the operating system, if you actually need them. If you don't need them, throw them out. And then you can say, is that only the case with Java? Well, I did a very naive way of looking at other languages, and this was the new research from yesterday. By the way, OpenJDK, the images of OpenJDK are deprecated. Don't use them anymore. If you look at the README, it says, hey, use something from a vendor like Azul or the Eclipse Tamarin or whatever. OpenJDK latest image currently is based on Java 18 for whatever reason. But you see, it's like that one is based on Oracle 8 Linux. The others are based on Debian 12, and you see there is a variety of vulnerabilities. Some come from the operating system layer, some come from the application layer. So what can possibly go wrong with a container image? What kind of vulnerabilities are there? Well, in some cases, or in many cases, we use functions from the operating system or binaries from the operating system to do certain things because they're there. Let's go back a couple of years ago to an old image, and we're going to use, who've heard of image magic? It's a tiny package within Debian that does image shrinking or image resizing. And this one had a vulnerability. Image magic was shipped to, in this case, Ubuntu 5, Ubuntu 7, and some other versions. And it was so tragic that they called it image tragic, which I think is funny. So what went wrong? Let me just show you. I have this application here. Okay, let me look. Yeah, it's running. Cool. I have an application over here. It's Node. I'm sorry, but it was the easiest way out. It doesn't do anything. It uses basically a web front end to call image magic to resize an image. So normally, I just choose a file. Let me choose an image. Let me choose this one, and let me. Oh no, let's not choose Sam. Let's choose Brian. I don't want to expose my colleagues. So, and it resizes to a thing that is suitable for Twitter or X or Y. I'm not sure how it's called out nowadays. So that looks cool, but it uses image magic from the operating system under the hood. Well, what if my image looked something like this? I will enlarge it in a second. Like this. RCE1.jpg. So you can all see what's going on here, right? Hopefully. Or maybe I can zoom it in a bit. So what you see here is that this is a valid entry in image magic. It's basically just like you have with SVGs, that you can describe how a certain image is. One thing it pretty much does, it says, let's get the stuff from a URL localhost something, and pipe it with touch RCE1. Basically, if I say, if that image, that JPEG is not there at that URL, do something else. This is allowed because image magic doesn't do any proper input validation. So because I'm using image magic from the operating system, I can use this. So currently, this is my system. This is the, as you can see, this is the container it runs in. As you can see, we don't have any RCE file called RCE1 or something like that. So let's just upload that file that I showed you. So let's do so. Yeah, thank you. Let's Sheldon do it again. And let me show where did I put this one? I should have prepared this, I guess. Exploits RCE1.jpg. All right, let's upload this one. This is running in a container. I resize it, and I won't get anything back because it's like that URL.jpg doesn't exist. However, in the meantime, if I'm looking back to my container, and I'm doing again, you will see that I just created a new file. But if I can create a file, I can create a file with content. I can come back tomorrow, hit that content. If it's a script, nice. Good luck tomorrow with your post-mortem. What the heck happened? Or even worse, if I can execute arbitrary commands, I can do things like reverse shell attacks because I'm in your system. What is the default user for a Docker image? Root. So if you didn't look at that, I'm root. Nice. So you see, if you're just using things and you're not taking full attention on what you're actually doing, like, hey, works on my machine, ship it. That's how we work, right? Might not be the right case. So second thing is only use what you need. But isn't that the same? Well, not particular. If you go onto websites to see like how do I create a Docker container from my Java application, there are still, unfortunately, some tutorials that show you something like this. Well, question, what is wrong with this Docker file? The simple answer is everything. What am I doing? I am using an OpenJDK image from the internet that has Maven 3 streamlined in. So think about it. I have OpenJDK, which is my built, or is the language model, the full Java development kit, and I have a build tool. Next, what I do is I copy all my source code in it, and then I use my build tool to actually compile and run the Spring Boot application. What do I actually need? Think back of the days when we just deployed a thing in a server that was somewhere, I don't know, in the basement or under your desk. You just need the artifact. You don't need the full JDK, a build system, and your source code. You know what happens if people are getting in? They can just alter your source code, rebuild your system, and reboot it, and it does something completely different that you didn't expect, and it wasn't even down. So, by the way, this was 1.3 gigabytes. My Spring Boot application was literally doing one endpoint saying hello world. 1.03 gigabytes. But if you think about how should I build an image? Well, if you want to create the artifact using Docker, you can perfectly do that, but use multi-stage builds. Your build image is not particularly the image that you need to put into production. You can deviate from that, and you can deviate from that in different steps if you want to. Streamline things in, putting things out. It's just like Lego. So I rebuilt this one. What I'm doing here is I am actually still using that first part to build my system, because I need Maven, I need the JDK 17, and I need my source code. But then I reference it as built. So for me, it's a reference now. In the second step, I'm using something different. I'm using an image based on Eclipse Xamarin 17 Java runtime environment. You know, that's the other thing. You only need the Java runtime environment to run that thing, based on Alpine, because I don't need glibc. The only thing I do is copy the artifact, and then simply do a java -jar. So that means in the container that it produces at the end, I don't have the JDK, I don't have a build system, and I don't have my source code in it. And yes, technically you can decompile source, but you get what I'm saying. This one was only 270 megabytes. So that's easier to store, easier to spin up, easier to scale. Think about it even more. If you need to put in things like credentials, like say, and this is just a hypothetical thing, say I'm putting in credentials to go to a certain repository to download certain artifacts to build my system. You don't want these traces in your final image, because then you can look at the history and actually retrieve these credentials. If you don't do it properly, maybe you can obfuscate these things. But now I know for sure that these things stay in my build image, that build image gets thrown away, and in my final image I just have the artifact, because all the stuff that I need there and I put in is not there anymore. It's thrown away, and I only end up with the artifact in a minimal image that I need to use. And then probably there are some smart asses in the room like, Java 17 JRE? But Java 17 doesn't supply a JRE anymore. That's true. As of, I think it was Java 10, or Java 9 even. Like Java 9 introduced the module system. Who uses modules? That's what I thought. Nobody uses modules, because why should you? Well, the module system is created for you to create a minimal Java runtime and only the stuff that you need. So Java doesn't supply a Java runtime anymore. You can build it now yourself with JLink. However, some vendors like Eclipse or Azul or anyone might pre-compile a Java runtime for you, basically stuffing everything in that you might probably need. So things are that it might still be too big. But you can use JLink yourself to minimize the thing, not only for performance reasons, but also for security reasons. This is how I can use JLink. And what you see is a huge amount of modules that I'm putting in. This is basically all the modules that if you Google it, you will see like, oh, this is probably the modules you need for a Spring Boot application. But like, probably, that's not very accurate, right? It's just guessing, hoping it works. So it works on my machine, ship it. There's another tool you can use. You can use JDAPs, Java dependencies. And with JDAPs, you can find out from a jar and its dependencies to see which modules in Java it's actually using. So what I'm doing here, I'm outputting all my libraries that I'm using to my deb/lib, and my jar is actually the jar. And with this, it will give me back a list of modules that I can use in JLink to actually create the Java that I needed, fit for purpose. It looks something like this. Whoa, that's a lot. All right, let's focus on the parts that we need. What I did here is a Spring Boot application. I did this after the fact. I said, okay, Spring Boot application was already built. Let's unzip it because the jar is just a zip. And let's make sure I have all the libraries here. And basically, the libraries end up in bootinf/lib. So I know that all my external libraries are there, and I have my jar. So I used JDEBs in this case to look over all my libraries, my third-party libraries, plus my jar, and I output this in a file called jdebs.info. And yes, there are other ways of doing this. But because I did this afterwards, I unzipped it. That was my choice. Next, I'm using that jdebs.info as the input for JLink to create my specific Java runtime. These are all tools that are just shipped to you for free. Next step, in this case, I decided to use Debian Bookworm Slim. I'm streamlining I'm copying my created Java in there, create my, or put my artifact in there, and again, doing a Java minus jar. So in this way, I can slim it down to everything I need and nothing more, which in this case now, I'm absolutely certain that I have the slimmest version that I want to use. Yes, obviously, I'm still using a Debian Bookworm Slim, but it can be any base image that you're creating in your company. And that might be something that you want to do company-wide to say, like, hey, we're all using this image, because then we know this is safe, this is secure, this is small enough, and then streamline your own JDK in it, or if you're doing any other language, any other binary in it, and then go from there. So the full Docker file looks something like this. I will publish this, so you can make a picture, but I will publish the slides anyway, so you can see that. The other thing you can do, I unpacked the jar, which seems inconvenient. So what you can do as well, if it's a Maven project, you can basically put in the Maven dependency plugin and say, like, hey, every time I build, I want the outputs of all my libraries into a separate directory, so I can point JDEBs to that right away. That is what I suggest normally, but if you do it after effect, you can also always unzip the full jar if it's a fat jar like the Spring Boot application. If you want to know more, I wrote all of this down in a blog post, step-by-step guide. And it's pretty easy. You just have to put in some work that you know, like, okay, how does JLink work? How does JLibs work? What kind of parameters do I need? But if you did that once, it's in the file. You don't need to touch it again, pretty much. All right, let's go on. Who knows what the least privileged principle is? One person, thank you. Two people, love it. Think about it. The least privileged principle is nothing more than I only give you the privileges you need and nothing more, which seems fair. If you do less, you cannot do your job. If you need more, then you might have possibly a chance of a data leak. Think about it. If you're in the hospital and there's something wrong with you, who do you want to know what's actually wrong with you? Just your doctor that actually is taking care of you, or the whole hospital and your insurance company? Least privilege principle. Only your doctor needs to know what to do because he needs to know the facts to cure you. Your insurance company doesn't need to know because it's none of their business, right? So apparently we do not provide that kind of ruling or state of mind into our applications or runtimes. So I did my multi-stage build. What is missing here? If you think about the least privilege principle. Thank you. User. Absolutely. We already said that the default user is root. So my application here runs as root. Root has full privileges on basically everything. And the file system, I can access it, I can write it, I can overwrite things. So there's only one step away of being God mode. That is not what we want. So let's focus on that image that we're actually putting into production. We build our artifacts, not needed anymore. Second step. basically what we need to do is that, like we did before on our physical service, create a specific user. Done. Oh no, it's these 3 lines. This is an Alpine image. So it can be a little different if you're on a Debian or an Ubuntu thing. What I'm actually creating is I create a user without terminal access, without a home directory, etc., a minimal user. Then I chose, this was a choice, I chose to give them ownage of the project folder. So it owns the project folder. Within the project folder, it can pretty much do whatever it wants, because that's what I need for this application. And then the 3rd line is the most important line. Call that user. Because if you don't do that, it still runs at root. Look at some other containers, like the Node.js image, for instance, has a less privileged user. But you need to call it. If you don't call it, you still run as root. So you can do all the preparation what you want, but you need to call that user. If you call that user, the next step, in this case the entry point, will get called as my user that I just created. So now I can bind it back and make sure that my security is a layered approach. So if somebody's in my application, it doesn't, and it can break out into the file system or outside of that, it doesn't have God mode. But because security is just making sure that you're not making it impossible, but you make it improbable, that they're not making more damage than they should be. And just thinking like, but I have a firewall. Sure, buddy, you have a firewall, good for you. But if somebody breached that firewall, you're done. So that's why you put multiple layers of defense in. It's not like, okay, I have a garage door, or I have a garden with a fence, and I lock the fence, so I don't need to lock my door to my house anymore. Well, this is pretty much the same reasoning. You should. Okay, we did all the preparation. But now you still need to scan your Docker image, and in this case your Java application, during development, but also after development. Because it can be saved now, your base image. But maybe somebody found something there is like, hey, I can exploit that in a certain way. If something is not found yet at the point of going to production, doesn't mean it's not there. Just like life on Mars. We don't know if there's life on Mars, we just didn't find it. Same here. We asked developers during our 2022 State of Open Source Security, or 2019, we did it again in 2022 with pretty much the same results. When do you scan your Docker images for operating system vulnerabilities? And 50% says, we don't. We're just using it because it works on my machine. Obviously, I work for a tooling company. Snyk provides tooling, and simply what you can do if you, for instance, you pull Eclipse Xamarin 17, I can say Snyk container test Eclipse Xamarin 17 JDK, and it comes back with something like this. Hey, you have a ton of vulnerabilities, well, ton, 18 exactly, and these are the vulnerabilities that are there, and then at least you have information on what to do. As in, I choose to ignore it, which can be fine from your situation, but that you go into threat modeling, and I don't want to go into that because that's boring. But depending on your situation, you can choose what to do with that. You can also do that for a specific container. Like, hey, I created my own container, I streamlined things in. You can scan that, and it will look at both your operating system layer, but also the layers below that to see if there are vulnerabilities with the binaries that you streamlined in. Let's go to the application as well. So you're putting in an application. Say this is your application. How much of that application is your code? Yes, this, exactly this. This. Who of you does pair programming? The rest of you does code reviews. Yeah, okay, cool. It's fine. No, but we're very proud of the piece of code that we create. At least 2 people need to look at it before we can push it to production. Sure. The question is, who looks at it? Is that the junior developer that just entered my team? Hey, junior, you got 20 minutes. I worked for 3 weeks on this feature. Good luck. No, but at least we have some process around that. But then that big yellow bowl is the things like framework dependencies and all the stuff that we pull in, including your Docker image. How do we take care of that? It works. Don't touch it. That's in most companies how it works, unfortunately. Once it is in your manifest file, either Maven or Gradle or SBT, doesn't matter, we're not getting it out because it might break. We've seen over time that most problems in these cases are the transitive dependency. So you're putting in a Spring Boot starter, but that means from a Spring Boot starter, you pull in a ton of other libraries, because libraries use libraries, use libraries, use libraries. And then 3 layers deep, something went wrong. And guess what? In Java, everything is available in the class path, so it can be lifted into memory. So that means it can be used in a chain of attack. Oops. That's different in some other languages, by the way. So what can possibly go wrong with vulnerabilities in my app? Well, I have, who was here at the keynote of Simon Brown? The architectural keynote. He made a comment about Apache struts, right? Yeah, I will show you why. Say, I've got an application here that runs on Apache struts. And, oh, this is on my local machine. I have it here on the internet. As you can see, it runs on Heroku, right? It's real, it's live, works. It runs on Apache struts. The problem with Apache struts is that the version of Apache struts that people are referring to us is the one that got Equifax, a crediting company in the US, in trouble. They were hacked because they were using this framework, and there was a vulnerability in it. Long story short, the vulnerability was already patched. They didn't know. They just went on with new features, and 3 months later, they were hacked. 75 days later, after the hack, they found out somebody was in. 140 million customers were compromised. Not something that you want. But the hack was quite easy, because Apache struts, you can does a lot of things with routing and all sort of plumbing things for your framework. Hopefully nobody's using that anymore. Who's using Apache struts? Yeah, I wouldn't raise my hand as well. Gotcha. So what I can do, I can just do a curl request with a specific header. This header. Right? Pretty clear, right? Who recognizes this header? It's an invalid header. It's an invalid content type. Again, long story short, invalid content type, I go into an exceptional flow in Apache struts. I'm allowed to utilize their expression language, OGNL, and with that expression language, I can interfere with the objects in memory. Or even worse, I can create new objects, which I'm doing here. I'm calling a new process builder. That process builder, I say, okay, spin up a bash with a certain command, and that command can be anything. So doing that, let me do this one. So what I'm doing is I use that header, and you can just download that header. The header is freely available on the internet because it was from 2017. If you're still using that, you are in trouble, my friend. It's not running on localhost, it's running on Heroku. So what I'm doing, I'm using the header, I'm making a substitution. That word command that you saw goes out, the word env goes in. Env is nothing more than showing my environment variables, just a Linux command. And it's not on localhost, it's a curl -v -x get to Heroku. Now let's see what we can get out of this. And what you see here is that because I reroute the output or the input write to an output writer, I have the environment variables of my Heroku pod. And then you're like, yeah, sure, like, environment variables. Well, if I can call the environment variables, depending on what the usage is of that user, I can also create a script. I can do a reverse shell attack, depending on if you actually thought of it as putting it to root, because Heroku is nothing more than a virtualized container. So this can be one step into the application, or actually getting out of the application. Depending on what is in your system, I can misuse that to do something else. So this is my way in. Probably most of you will say, but I am not using struts. I am using Spring Boot. Who's that? The rest is not like, I'm not sure if I want to say yes or no. That's no problem. I have a Spring Boot application here. And this is a Spring Boot application that basically is nothing more than a grocery list. If you can see here, I am putting grocery lists when I'm spinning up that Spring Boot application, saying beans for 50 cents, milk for $1.09, etc., etc. Well, as you can see, the item, the entity is not important. It's an ID, a name, and a cost, and some getters and setters. Yes, I could have used records or whatever, but this is old. Let's go to the repository. This repository uses the CRUD repository, like we all do, right? It's easy, just do that. Generate stuff for you, which is great because I do not want to create yet another CRUD endpoint by hand. But we have something special here. Repository REST resource. This transforms my CRUD repository into REST endpoints without doing anything. Great for prototyping. We all know what happens to prototypes, right? MVPs, proof of concepts. Once it hits production, it will never get out. The thing is, I already spun up this application, and it brings me, this part of Spring Data REST, brings me to my hell browser. My hell browser is nothing more than to explore whatever is happening. I can do something like this, items/1 by default, and I will get my first item, which is beans for $50. Cool. I can also do things like, here, search, find by name, name is beer. Okay, also cool. So what's the problem in here? Well, Spring has an expression language, SPEL, the Spring expression language. Let's take a look at that one. Where did I have it? I think here. Let's get the environment variables just to have a really smooth experience. So I'm going to use this. I'm going to explain it in a second. Let's clear my screen, and let's dump it here. What I'm going to do here is I am going to use a curl. That looks weird. Anyway, I'm going to use a curl patch request. And a patch request is something similar to a put request, but it has a body. And in this case, the body can contain JSON. This JSON is nothing more than using the Spring expression language. And as you can see over here, it's using runtime.getRuntime.execute env for environment variables. So note that it is running towards my endpoint that was generated for getting my first item out of my database, item/1. Well, it's not running on 8080, it's running on 8042 because that's the number that is the most important to everybody. Hope somebody understands that reference, but it doesn't matter. So if I do this, you will see, because I reroute the input stream to an output stream, you will see this, that these are the my local variables, my local environment variables. So by doing this, I can introduce again, even with Spring, I can introduce these kind of things because there's an expression language available. What can I do about this? Update to newer versions, because I cheated. This version was old. If I scan it over here, you will see that I connected my Git repo here, and you'll see that it has, data commas has an arbitrary code execution. Oh, that's maybe a little bit too big. An arbitrary code execution, and as you can see here, it was in Spring Data REST 1.55. So if you're still on Spring 1 something, take a look at this. Hopefully not. And it says to me like, hey, you should at least go to 2.06 to get rid of this vulnerability, and done. So that is one thing. But say you were already in, your application is fine. Great, right? We already saw this application because I hacked it with that Apache struts thing. But I put this into a container. Let me show you how I wrote the Docker file for this one. I have too many things open. Can you recognize that? You probably have the same, like the amount of tabs you have open during browsing or YouTubing during work, right? Yeah, got it. Docker file. Let me show you the Docker file. Let me enlarge this. So I'm using a multi-stage build. It's based on Java 8 because it's an old application based on Apache struts. Very, very old. I'm doing something with building. I'm copying some stuff over, and for my second layer, I am using Tomcat 8.5.21 because I need an application server. So far, so good. However, Tomcat 8.5.21 is a little old. Say ancient. The problem with Tomcat 8.5.21 is that it has an arbitrary code execution. Yes, I love arbitrary code executions. Can you Can you guess? What the problem is that if you use this version of Tomcat, this container that I just pulled off the internet, it was possible to, it's possible to upload a JSP file to the server via a specially crafted request. Just JSP could be requested, and any code it contained could be executed on the server. Let's go to my favorite database, the exploit database. People already did the hard work for me. I love that. This is a Python script that does that specially crafted request for me and gives me two payloads. First payload is a JSP file with an output println with all A's, just to show if it actually executes that code. If that works, we go into the next step. And the next step is a payload that is a form. That form contains a text box and a submit button. Every time I hit submit, as you can see here, runtime.get/runtime.execute whatever was the value in that thing, and I show it below. So I basically create myself a web shell without even touching your application. Just to show you that I'm actually doing this, poc.jsp does not exist, and pwn.jsp does not exist because they get created by this hack. So I loaded I loaded the Python script, so let's check. That's the first command. So let's check if it works. And it said it's vulnerable here in yellow, so let's check if that actually is the case. poc.jsp now existed, so I'm not touching the application. I'm just intruding the Tomcat, which was provided to me in that Docker container, and all A's. So it executes JSP. Ooh, nice. Let's go to the next step. And PWN is the next step, and it now says here in the bottom, uploading web shell. All right. Cool. I'm root. So I can now do anything that I want. I can install my Bitcoin miner, do some, I don't know, whatever I want. Because I'm root in this container, I have availability in as shell commands. So it's free playtime for me. Even if you're not, even if I'm not touching your application, I'm now just attacking your Docker container. But both are phases of attack that can be misused by people. The thing that I could have done is scan it, and I scanned it here on my local machine with my CLI because I like black screens, and it showed me that my application had a ton of vulnerabilities, and my my container also had a ton of vulnerabilities. It says to me here, you're using base image 8.5.21, which has over 735 vulnerabilities and 70 critical. If I need to stay in that 8.5 range, I could just update to 8.5.99, which only has 28 vulnerabilities, and 0 of them are critical or high. If I do that, just update the image, not touching the application. Updating the image, this is not possible anymore. Does it make sense, even though your application is not changed, to every once in a while change your Docker image to a newer version? Because people tend to patch things. So looks good, it works. Stop touching it is not a good approach. Last thing, and this is more on an architectural level. We need to build a container to rebuild it. What do you mean by that? Well, say this is your Java application in your container again. Duke is suffocating, so what do? We just create 3 Dukes. At least one will survive, hopefully. No, but what you want to do, especially if you have a container orchestration, you probably have multiple pods or multiple versions of that container live. Because you want to scale. You might want to scale up and down. If you're a web vendor like Amazon, you might want to scale up during Black Friday and down afterwards because it's a waste of money. But say you have proper logging available and proper monitoring available, and you see something is fishy in the 3rd container, which might indicate that a hacker might be in and might be snooping around. What is the first thing that you need to do? Boom. Blow it up. At least be aware that you can just demolish that container, because you don't know how easy it was or how hard it was. At least the immediate effect is gone. And then you want to spin up a new one, and hopefully with a newer version that fixes the problem. But at least you can get rid of the immediate effect. And we should be aware of that. So A lot of people, and hopefully you not, because you are all developers. Sometimes I talk to managers and they say, well, you can just lift it and shift it, right? Sure. But if I lift and shift a monolith, I have a database in, I have logging in, and I've got memory things like, I don't know, caches and that kind of stuff are built in that monolith. So just lifting and shifting it does not work, because then I cannot just blow it up because I lost everything. So we need to make sure if you create an application to be modular or to be in a container and to be scalable, and it seems obvious, but I hope you do that, that these things are outside of that container and can be scaled in a different way, so that you can upscale and downscale your containers in that way, that if something is wrong from that perspective, you can blow it up and you can recreate it right away. Just let that land in. Just by using a newer image, 44% of all Docker problems can be fixed. We ask people, how do you find out about new vulnerabilities in already deployed containers? Let's say it's less than the majority that says I probably won't. 20% of Docker images vulnerability can be fixed by just rebuilding that. Why? Because people don't use tags or don't specify tags or use a dynamic tag. For instance, if I do this, Ubuntu latest, and then I get a Python installation, that will be different today than it will be tomorrow. And we can argue if this is a good approach or not, but if you use this approach, then you know that rebuilding that image, the latest Ubuntu image, will be different in a week or in 2 weeks. Probably fetched new security upgrades. I would say go for deterministic builds and make a specific hash on it so you actually understand what's going on. But if you take this approach, make sure that you rebuild over and over again, say weekly, monthly, depending on your threat level. If you do that locally at least, make sure you skip the no, you do the no cache thing, because or else you're not sure what's happening, because I don't trust computers. Anyway, let's wrap this up. If I come back to the 5 things I wanted to show you, it's simply like choose the right base image. Not just because it was there and ChatGPT said, this is fine. Do some research. There are more versions of a base image for a reason. Use only what you need. You don't need the full JDK. You need a runtime. Either pick a Java runtime from a vendor that is precompiled for you, or create your own using JLink, because it's not that hard. You just need to copy-paste whatever I did that I got from ChatGPT. No, kidding. No, but do some research on that if you want to make it smaller, but only put in what you need. Don't give bad actors more ammunition than they need. And it might not look as ammunition, but it might be possible that they use it as ammunition. Some things individually might not be vulnerable, but in a chain of attacks can be vulnerable. And I have tons of demos on that, but we don't have the time for it. Oh yeah, don't run as root. Did I say that you shouldn't be running as root? Please don't. So put a lesser privileged user in, or create a container for yourself that already has that lesser privileged user for the whole company, but make sure that you actually call that user. Scan your applications and images during development, but also after. Because if you put it into production and you leave it there and you pick your next task from your Jira board, who uses Jira? Yes, exactly. Everybody recognizes that. And the task is like, if I click on X, it must do Y. Nobody cares about security unless you get broken. It's always feature-based. But that thing already lives in production. Why not scan it at a certain level? Because once you go to production, you know what the base image is. You know what the binaries are, they're static. You know what the dependency graph is of your application. So that is static data. And you can scan that on a regular basis. And we can do that, for instance, by doing sneak monitor. But the thing is, it pings you when something goes wrong and you can take actionable things. Like, hey, should I upgrade or not? But at least you know instead of, I don't know, works. And last, build to rebuild. So make your architecture in such a way that you can demolish it right away and spin up a new instance of a container if you need to. If you want to know more, these were only 5. We have 10 best practices. 10 sounds better than 5. You can find it on our blog post. I wrote this one. And I hope this was useful. So make a picture. 5, 4, 3, 2. And thank you so much. Appreciate it. If there are any questions, feel free to ask now, come up to me, ask me later. I will be around all day, but there's one question here.
Just one question. So when you use the JRE using the J-Link,
Yeah?
what is the best practice, for example, if you need some debugging tools?
Oh, the question is, if we're using J-Link and to build our Java application, what is the best practice to use tools in for tracking or debugging and that kind of stuff? Only use it when you need to. Only use, in many cases, you don't need that right away in production.
Yeah.
And then it's like, okay, something happened and we want to reproduce it.
Exactly.
At that point, build an image that has these tools in and try to do it again. So, like sandbox it. That's what I'm saying. And not put everything already in, depending on your threat level, because there's always, this is the consultancy answer, I'm sorry, it depends. But if your threat level is not that big and you don't have PII data in it, sure, you can do it, but then it's also a performance setback. So you have to look at performance things, you have to look at scalability if you want to be scalable from the get-go. It might not be a threat, but it can be, because most of these tools have elevated privileges.
Yeah, of course. I mean, stuff like doing a...
What I mean is stuff like doing a thread dump or doing a memory dump, right? When you want to analyze, you have a memory leak and see what objects are running amok.
I agree that these things can be useful. If you feel like you need them, you can pull them in, but in most cases, for production images, you don't want all these tools running in the background right away. So in most cases, when we were doing this is just my opinion on things, when things go wrong and we know what actually went wrong, we want to try to reproduce it. And we do that in a sandbox container that has that tool. So we build a specific container with these tooling streamlined in, and then do the thread dumps. Make sense? All right. Enjoy the rest of the conference. Cheers.